This is a class 12th RD Sharma solution. We are taking chapter 19 VSAQ and this is for indefinite integrals. Very short answer questions. Now the main key is we have already completed 32 exercises. Few of those exercises contained almost 70 questions. So this exercise will take us from 1 to 32 exercise and all the concept will be used here. 1 plus cot x divided by x plus log x sin x dx. Now since this is VSAQ or short answer question, we generally see the denominator and we would like to get the numerator out of it in the indefinite integrals. So there are certain options like if you have under root, you need to eliminate that thing. So all those concepts will be used here. In this case, we will take this x plus log sin x as a t. Now let me tell you that t, you can take it as p or u, any letter from a to z which is not matching with what is given in the question. So that can be used. I'm using t, you can use p, but trivially we are using t. So this is dt by dx. We are differentiating with respect to x. This will be 1 plus log sin x is 1 by x, that is 1 by sin x, and then sin x will be differentiated, which will be cos x. So what do we get? We are getting 1 plus cos by sin is what? It's cot x. But 1 plus cot x is along with the dx, so we'll take this dx on the right. So 1 plus cot x dx will be equal to dt. So the integration will become something like this after taking into consideration the replacement or t which we have taken. It will be the numerator, which is 1 plus cot x dx. We already got dt, and x plus log x was taken as t. And dt by t is directly log modulus of t plus a constant of integration. Now initially we took t as x plus log sin x. So the final replacement will be replacing the t with the original thing. That will be log modulus of x plus log sin x, and inside the modulus sign plus a constant of integration. This is your final result. Now those who have already known me, that I already say about the logic and the concept, but the actual solution I generally show you like this so that you can refer it later. And all this English thing and the symbols are very important, vital, integral to the solution of mathematics. Next one is e raised 3 log x multiplied by x to the power 4. Now all these questions, they will need a lot of understanding about the exponential and logarithmic functions. That means if this e to the power 3 log x, now you already know this, we have discussed this, that if you have a log x, it simply means it's x to the power a. That means it's log x to the power a. You can call it in another way, that in a general terms, log x to the power y is y log x. The power comes in front. So the concept is like this. So this 3 log x will become what? With this discussion, it will be log x to the power 3. Now you have x cube and x raised 4. But still, there is one more thing as far as exponential functions are concerned. E to the power log x cube. Now e log e to the power log e cancels out. That is, if you have e log m, say, you can take any letter. I'm just explaining you that if the base is e and you are raising it to the power e log, so this gets cancelled, only m will remain. So the answer will be x cube in this case, the result actually. So we'll take this x cube. So whole e raised 3 log x can be written as x cube, and once it is known, this x cube will be multiplied by x to the power 4. You have a dx here. X cube into x raised power 4 will be x raised 7. And x to the power n integration is known to you. Let me tell you here, because it is going to come again and again. Integration of x raised n is simply x raised to the power n plus 1, and this is with respect to dx. So x raised n plus 1 divided by n plus 1 plus constant of integration. So whatever n is there, that is in this case 7, you can use it. So it will be x raised 8 divided by 8 plus constant of integration. This is your integral. Now this is how you're going to write it, because I told you very deeply what all concepts are used here, but this is how you have to actually write it. Next one is x square sine x cube. Now if you take x cube, the differentiation will give you x square. So we will take this x cube as t, will differentiate it dt by dx. This will give you 3x square. This dx will go here on the right and 3 will bring in the denominator. So dt by 3 will become x square dx. Now this x square dx we will take together and we'll replace it by dt by 3. So the integration will become something like this, dt by 3, 3 can be taken outside, 1 by 3. Then we have sine x cube, and x cube was taken as t just now. So this will be sine t. So let's take this as sine t dt. So we'll integrate it now. Sine t integration is a negative cos t, 3 remains here, plus a constant of integration. But still there is one more thing needs to be done, which is t equals to x cube has to be replaced. So the integration will be minus cos, in place of t will have x cube, divided by 3 plus a constant of integration. That's your final result. So how you are going to write it, that's what I'm showing it to you right now. You can follow this. Now, there are various questions where there is one thing which we put as t, the differentiation comes out by itself. So if you take this 10x as t, please remember there is one more question just coming with this same scheme. So this t, if you take it as 10x, and when you differentiate it, dt by dx will be what? It will be sec square x. This dx can be brought on the right. So this dt will be equal to sec square x dx. This integration will become like this. Sec square x dx will be dt. You can just write dt in place of sec square x dx, and then 10 cube x, t you can take. T cube will be 10 cube x. So t cube will come. Now this x raised n integration kind of thing we can apply here. It will be t raised 4 plus c. Final replacement of t as 10x can be done, and this integration will be like this. It will be 10 raised 4x divided by 4 plus a constant of integration. And this is how this will be done, and this is a very easy question if you have done all the exercises of indefinite integrals. E raised x sin x plus cos x. Now this, if you remember, when we were differentiating or when we are learning this differentiation, just multiply this first. E raised sin x plus e raised x cos x. Now you need this. How can we get this? From our previous experience, we know that we can put this t as, so this t will be equal to e raised x sin x. When you differentiate it, it will be dt divided by dx. This will be equal to, we will apply the product rule, e raised x sin x will be cos x plus sin x. This e raised x will be e raised x. Now you see the similarity, actually it's this whole is dt only. So whole expression we have actually got after putting t equals to e raised x sin x. So this whole will be simply dt, and the integration of dt is simply t, and this will be t plus constant of integration. This t is e raised x sin x, which we initially imagined or we thought. E raised x sin x plus c is the final result. Now this is how you are going to write it, and this all the symbols and let all this is your responsibility, which I show you. Now we have just done a question like this, and I pointed it out that this question is going to come again. So same thing we are going to do here. We just put t equals to 10x. Then we differentiate dt by dx. That will give you sec square x dx. That is dx I am taking on the right hand side. So this whole sec square x dx is simply dt. 10 raised 6x is simply t raised 6, because t was taken as 10x. So let's take this. It will be simply t raised 6. This whole has become dt, and when we integrate, it will be t raised 7 divided by 7 plus constant of integration. T was earlier 10x, which we put here, 10 raised 7x divided by 7 plus a constant of integration. So this is how you are going to do this, and this is for your reference for later. Now this 3 plus 2 sin x is in the denominator. Numerator is cos x. Now if you take sin x equals to t, you will get a cos x for sure. But you will get 3 plus 2t. You don't want that because it will again increase the effort of solving this kind of question. So rather than taking sin x as t, just take this t plus 2 sin x, because 3 and 2 will eventually be easier to maintain when you differentiate. So when you differentiate dt by dx, this 2 sin x is there, cos x will come after differentiation. So cos x dx already got, this dx goes here, t I'm bringing on the denominator. So cos x dx will become dt by 2. So this integral will become, cos x dx will be dt by 2, so dt will come here, 1 by 2 here, 3 plus 2 sin x. So we have taken this whole as t, so dt by t, and this will be half, dt by t will be what? It will be log modulus of t plus constant of integration. In place of t, replace it with 3 plus 2 sin x, which was earlier taken. So half log modulus of 3 plus 2 sin x plus a constant of integration will be the final result. Now this is how it will be completed. All the symbols on the modulus signs and sins and all this has to be done. Now we have just done a question like this, and we need to get this e raise sec x. Just multiply this first. So this e raise x sec x, then we multiply e raise x sec x with 10x. So this will be e raise x sec x 10x. Now what do we consider, or what do we take so that we get whole of this expression as we just did in the previous questions? So let's take e raise x sec x after, just deliberating that what we have done in the past, the differentiation activity. So dt by dx will be e raise x sec x 10x. I'm applying the product rule. Sec x e raise x will be e raise x. So these two terms are exactly same. So this whole of the term which is given in the question can be written as just dt. So again you are just integrating dt. So you are just getting t here plus a constant of integration. But we have taken t as e raise x sec x, so we can write it here plus a constant of integration. This is your final result. So this is how it will be done, and this is how it will be written, and take it as a reference. Try it yourself. All these questions are already been done by you. Now there are two questions which are almost similar, and we have this log x raise n. So log x raised y is what? We have learned that it is y log x. So n can come in the front as an exponent, you can, as a coefficient you can say. So this will be n log x divided by x. And then what is the use? When you take log x equals to t, 1 by x can be achieved. That is dt by dx will be 1 by x simply. Dx can be taken on the right. So dt has become dx by x, which is already given in the question. So we can do the replacement here. Dx by x can take place of dt, or dt can be replaced like this. Log x is t, n can be taken out. It will be simply t square by 2. N is already there plus a constant of integration, and t was taken as log x, which needs a final replacement. This will be n log x to the power 2 and plus a constant of integration. So this is n by 2 log square x plus a constant of integration. Now how this has to be done, again, this reference is very important for those who just want to do by themselves. Now this question is very straightforward because we have just seen that log x differentiation is 1 by x, which we know earlier also. So we'll just take simply t equals to log x. When we differentiate it, dt by dx will give us 1 by x. So dt will come as dx by x. Now this dx by x is already there, which can be replaced by dt. Log x was taken as t. So this dt, it's simply t raise n. So it's a general solution. X raise n, we were integrating earlier, x raise n plus 1 by n plus 1. In this case, x is taken as t. So t raise n plus 1 by n plus 1 plus constant of integration. But one more replacement is required. T was taken as log x. So you can write it as log x raise n plus 1 divided by n plus 1 plus a constant of integration. Now this is how it will be completed. I hope that this is very clear to you. You can do it by yourself. Alright. Now this question can be taken in the next discussion. Till then, thank you so much. Have a good one.